Welcome back to Soft Computing series. In this video, I will discuss fifth example on fuzzy sets. Watch my previous videos on soft computing and fuzzy sets. In soft computing video, I discussed three core methodologies of soft computing. In fuzzy systems videos, I discuss what is fuzzy logic, what is fuzzy systems, what is fuzzy sets, then operations on classical sets and fuzzy set, then properties of classical set, that is crisp set and fuzzy set. I also discussed fuzzy sets basic definition and terminology. I discussed 4 examples based on fuzzy sets. So this is fifth example on fuzzy sets. Let's start. Example is, consider two fuzzy sets to illustrate the above operations. Fuzzy set A is given with these 4 elements and fuzzy set B with these 4 elements. Perform union, intersection, complement, difference, Demorgan's principles. Let's start with the first operation, that is union. To perform A union B, consider set A and set B and select max element from both the set. Let's start. So this is set A and this is set B. Compare each element and select max. 1 and 0.5, max is 1. Write it as 1 upon 2. Second element 0.5 and 0.7. Select max, that is 0.7. Write it as 0.7 upon 3. Third element 0.3 and 0.2. Select max 0.3. Third element is 0.3. For the fourth element 0.2 and 0.4. Compare and select max, that is 0.4. Write it as 0.4 upon 5. So this is the set A union B. Let's perform second operation, that is intersection. For intersection, A intersection B, consider set A and set B and compare elements and select minimum element. Let's start. For the first element, compare 1 and 0.5. Select minimum element, that is 0.5. Write it as 0.5 upon 2. For the second element 0.5 and 0.7, select minimum 0.5. For third element, compare 0.3 and 0.2, select minimum 0.2. Fourth element 0.2 and 0.4, select minimum, that is 0.2. So this is A intersection B set. Now let's perform third operation, that is complement. To find complement of set A and set B, let's start. A complement equals to apply 1 minus mu A of x, that is minus 1 from set A. As in this set you can see elements start from 2, that is 2, 3, 4 and 5. So we can consider first element as 0 upon 1 for set A. Same way for set B, consider first element as 0 upon 1. That is, first element in set A and B is 0. Let's start and find A complement. So consider set A and use 1 minus mu A of x. Let's start. For the first element, so we have considered first element as 0. So let's start with the first element. 1 minus 0 will give 1. So that will be 1 upon 1 plus for the second element 1 minus 1, 0. Third element 1 minus 0.5, that is 0.5 upon 3. Fourth element 1 minus 0.3, that is 0.7. Last element 1 minus 0.2, that is 0.8 upon 5. So this is A complement. So A complement set contains these 5 elements: 1 upon 1, 0 upon 2, 0.5 upon 3, 0.7 upon 4 and 0.8 upon 5. Let's find same way B complement. Now to perform B complement, 1 minus mu B of x. So here we have first element 0 upon 1. Let's find B complement. Consider B. Let's start. 1 minus 0, that is 1. 1 minus 0.5, that is 0.5 upon 2. 1 minus 0.7, that is 0.3 upon 3. 1 minus 0.2 is 0.8 and 1 minus 0.4, that is 0.6 upon 5. So this is the set B complement. So we have performed union, intersection, complement. Now let's perform operation difference. To calculate difference, A difference B of two fuzzy sets, apply A intersection B complement. Consider set A and consider set B complement. So for A intersection B complement, select minimum element, compare and select minimum. Let's start 1 and 0.5, minimum is 0.5, 0.5 and 7, 0.5 and 0.7, minimum is 0.5, 0.3 and 0.2, minimum is 0.2, 0.2 and 0.4, minimum is 0.2. So this is A intersection B complement set, that is A difference B. To perform B difference A, use B intersection A complement. For this, consider B set and consider set A complement. Two sets are given, fuzzy set A and B, where first element is not given. So we can solve directly using these four elements, or we can also consider first element as 0 upon 1. So both ways can be done. So in this operation of A difference B, here I did not consider first element. Whereas in B difference A operation, I am considering first element 0 upon 1. You can do both ways. So let's start and find B difference A. Use B intersection A complement and use minimum. Select minimum element. Let's start. So consider set B and A complement set. Compare and select minimum, that is 0. Write it as 0 upon 1. Second element 0.5 and 0, select minimum, that is 0. 0.7 and 0.5, select minimum, 0.5. 0.2 and 0.7, select minimum, that is 0.2. 0.4 and 0.8, select minimum, that is 0.4. Write it as 0.4 upon 5. So this is B intersection A complement set, that is B difference A. Now let's perform last operation, that is Demorgan's principle. So in Demorgan's principle, there are two principles. Let's start with the first principle. First principle is A union B whole set complement equals to A complement intersection B complement. For this operation, consider A complement set and B complement set. Compare both the elements of the set and select minimum. First element, compare 1 and 1, select minimum. Here minimum will be 1. 0 and 0.5, select minimum, 0. 0.5 and 0.3, select minimum, 0.3. 0.7 and 0.8, select minimum, that is 0.7. 0.8 and 0.6, select minimum, that is 0.6 upon 5. So this is first rule, that is A complement intersection B complement set. So this is the first rule of Demorgan's principle. For the second principle, A intersection B whole set complement equals to A complement union B complement. Consider set A and consider set B. Let's start. Compare each element and select maximum. Let's start 1 and 1. Here max will be 1. 0 and 0.5, max will be 0.5. Write it as 0.5 upon 2. 0.5 and 0.3, max 0.5. 0.7 and 0.8, select max, that is 0.8 upon 4. 0.8 and 0.6, select max, that is 0.8. Write it as 0.8 upon 5. So this is A complement union B complement set. So for Demorgan's principle, perform two operations. So this is the first principle and this is the second principle. In this video, we discuss about union, intersection, complement, difference, and Demorgan's principles. Stay tuned for upcoming videos on Cartesian product in fuzzy systems. Share this video with your friends, like and subscribe to my channel. Thank you for watching.